So in the second part of the presentation, we will concentrate on our somatic solution, specifically examining the progress that Covaris has made in total nucleic acid extraction and from FAP sample and DNA shearing. FAP is here to stay. FAP was invented by Bloom in 1893 and has been used since then by pathologists to preserve tissue. Back then, I don't think that there was a lot of thinking about preserving also biomolecules, but that's what is used in comprehensive genomic profiling workflows, and it has a lot of challenges. The process is still very manual, and the deparaffinization is a long, hands-on process that is suboptimal. The nucleic acid are dextrose-linked, so they are tagged as damage. It's very important, it's paramount to find the optimal chemistry to reverse the dextrose linking. The workflow is very inefficient because it's hands-on and require a lot of multiple steps. What this entails is that also the scalability is limited because of all these processes. It's currently very difficult to scale it up, to address the need in tumor profiling, especially in this era where the genomic and transcriptomics are playing an important role in the clinical sector. Like for the germline solution, we focus on the ease of use and the performance and the economics. We develop a non-toxic, easy way to deparaffinize FAP. We enable a flexible automation depending on the lab's need, from manual to modular to semi-automated. We can guarantee high yield from small samples, small and precious sample, where being targeted and really looking at those FAP samples that have where the cancer has to be selected from the other tissue, providing a superior DNA and RNA quality that we show through amplifiability and through publication from clinical sample with our collaborator. And this enables also biomarker discovery. That is also in a field that is expanded. The economics are straightforward, reducing input requirement and reducing sequencing failure, where Illumina, from their comprehensive genomic profiling paper, they set this up to about 20% when it's from solid tissues. So this slide shows our offering solution for automation, as I mentioned in the slide earlier. We are partnering with Dynamic Devices for a modular solution with the R230 and a Lynx, where the only steps are moving plates around without the need of pipetting in and out. And this is valid from the paraffinization to extraction to purification and retrieval of the nucleic acid. A Covaris Hamilton ASHG workstation where there are only 3 touch points, that is, taking the plate and put it in the centrifuge, and everything else is automated from the paraffinization to total nucleic acid. And we also enable custom development, and this is addressing the need of those labs that are on a budget. They have liquid handler and automation platform that are sitting there, and we help them with our design of ultrasonicators and accessories to be implemented within their liquid handler and automation capabilities. Now, turning our attention to the performance of total nucleic acid extraction, we find that our process delivers equivalent performance between the manual and the automated method. This is a big benefit for the lab that want to scale up from small to high. And in general, we always provide a higher number of total nucleic acid when compare ourselves to the #1 competitor out there for total nucleic acid extraction. Our chemistry is optimized to extract specifically from small tissues, including fine needle biopsies and fine needle aspirates, and slice scraping. So now the concept of yield is something that is becoming less and less important, I would say, compared to the quality. How much can you amplify of the DNA and RNA that you are extracting? I would like to start by looking at the DNA quality that can be seen, especially I'm sure that this will resonate well with people that perform chromatin shearing, cross-linked with paraffin chromatin shearing. When we look at the extraction profile of the DNA using Covaris, we see that it's pretty similar to our competitor. When we use mechanical fragmentation, from the Covaris extracted DNA, we have this log normal distribution that is exactly what we would expect after mechanical fragmentation, with a target base pair that is identical when this protocol is used on a control, like Coriell DNA. When we share DNA from the DNA extracted from the competitor, we see a multimodal distribution of DNA with breakage point, pointing out to the suboptimal chemistry that is out there for DNA and RNA that is limiting the ability to share the DNA because it's all cross-linked still. And this is visible when we look at the amplifiability, very simple test where through PCR we amplified like housekeeping genes. For this one we used Illumina QC kit, and you see that the amplifiability from DNA extracted using TrueExtract is at about 3 to 4 times higher compared to the competitor. The same story applies when we compare RNA. This is RNA extracted using Covaris Mars solution, and this is from the competition. As you can see, the difference is evident, and it is a factor between 2 to 4 times higher compared to the competition. Another quality metric that was developed by QIAGEN is the DV200. You can see the comparison of the DV200 that the RNA has when extracted using Covaris compared to the competitor. The market recognition of our DNA fragmentation capabilities from FAP sample is evident in our prominent inclusion in several comprehensive genomic workflows, from library prep for the TrueSight oncology to comprehensive genomic profiling workflows like PGDX. This recognition extends to both shearing only, but also to shearing extraction. For example, the collaboration that we have with Twist that is titled Sequencing the Unsequenceable. Now, under the leadership of Jeff Conroy and in collaboration with the OmniSeq team, we have collectively worked to improve our FAP total nucleic acid extraction processes to help them deliver the higher standard in clinical genomic diagnostic and biomarker discovery. This remarkable journey started with them in 2017 and is still ongoing. Together we have worked and continually improved the Covaris automated FAP extraction protocol, and a cornerstone of our shared success is culminated with the exceptional performance as measured by the TSO 500 metrics and reported in this PLOS ONE paper. Notably, it demonstrates a matched result with just 20 nanogram of RNA and 40 nanogram of DNA, compared to the recommended 40 to 80 nanogram of DNA and RNA, yielding a 96.7% overall passing success rate for DNA and 91.4% for RNA. In a more recent paper, OmniSeq achieved a groundbreaking research with the first of its kind transcriptome analysis of T-cell priming markers, opening new horizons for targeted transcriptomic workflow in biomarker discoveries. Our collaboration showcases our commitment to advancing clinical genomics and biomarker discovery, positioning us as leader in the field. we are more than happy to collaborate, to learn, and to advance together. So for any question that you have, or any concern, or anything that you think we can help and work together in order to make things better and contribute to the advancement in the genomic field, please feel free to reach us, and we will be more than happy to have a discussion with you and set up a collaboration. Thank you for your attention, and I would like to introduce Madan, that he would be speaking about our RNA solutions.